So hi everyone, Senan the side, and let's continue our Doubly Linked List series. So in this video, what we are going to do is actually implement inserting at the tail, right? We've discussed inserting at head, we've made our classes, we've defined our constructors and destructors. We have already separated our files, the main file and the header file. So if you don't know what is going on, so be sure to check the previous video. But if you're able to understand this code by yourself, you're good. Okay. So what we have to do in this is actually implementing the insert at tail. See, in the last video we did insert at head. So this is our node structure. I'll minimize that. This is our not deep learning, but doubly linked list class. This is the constructor, destructor, insert at head, and the print function. So what we would be doing in this is we would be actually writing a function, which is what? Which is a void function, which would take which would do insert at tail. And again, this would take an integer value because you need to insert an element, right? So since we are inserting at tail, I know that I would be able to insert it at, right? So there would always be two conditions and two things that we need to check this. And again, starting with that, we know we can actually insert this element. So let's create that new node first. So node star new node, which is equal to what? New node, and what this would take is the value. Okay, so this would create the new node that we would eventually be inserting in the list. And as I talked in my previous video, you always have to check if a node is null, if a node is not null. That's all about anywhere that you have to define a linked list, a tree, or something like that. Okay, so you have this new node and which has a value val. Now you have to insert at tail. So the very first thing that you have to check if your head is null, because if your head is null, that means you have no list. If you have no list, what does that mean? It means that the node that you would be inserting, it's not just inserted at tail, it would be the new head as well. So if head is not equal to null, that means, or I could just write this as if not head. If head is null, what I do is actually say that my head is actually this new node. After that, I can just return because there are no links that I need to take care of. And this is the exact case like insert at head. If you see, if not head, head is equal to new node and return, because insert at head, insert at tail would be exactly same or would mean exactly same if you have an empty list. Okay, so let's get on with it. So this is the case where list is empty, and now we would write the case list or where list is not empty. Okay, so how do we go about that? Now to add an element to the end of the list, so I need to assign this to the node after, or I need to find the last node of this list first, and then I would have to do the relinking part. So first let's reach to the last node. So node star temp is equal to what? Head. And since we've already checked if head is not null, this thing, so I know that this head is actually a valid node. It's not a null node. So that is something that you have to keep in mind. And what you do is while temps next is not equal to null, right? So this means that if temp next is a valid node, what you do is you perform a jump. So temp is equal to temp next. So this would ensure that when you get out of this while loop, temp next is null, whereas temp itself is a valid node. So if temp next is null and temp is a valid node, that is the last node of this linked list, right? So we are at our last node. Now what do we have to do is to perform some relinking. And how many links do we have to assign? Only two links. The first one is the temps next should be this new node, right? Because this is the new tail. If this is the new tail, so the last tail's next node would be this new node. And since this is a doubly linked list, if this was singly linked list, we would return. But because we know this is a doubly linked list, what we have to do is to assign the backlinks as well. So new nodes previous is what? New nodes previous would be this temp, right? So temp to new node to temp. You have this cycle. So this would be temp. And the next of new node is already null because we have defined the constructor in that way. And the previous of temp, we don't care about that because we only need the temp itself. Now again, as I say in all of my videos, returning in a void type is a good practice, so that if anyone reads your program, he would know that that's the end of it. So insert at tail. So first you create new node, and then you check if head is null. So if not head, then that means that list is empty. If that list is empty, whatever new node you have created, that would be the head of this new linked list. And not just the head, it would be the only element in that linked list. And then you return. Otherwise, if head is not null, so that means head is a valid node. And if head is a valid node, I would have a tail node. I would have a node which is a valid node, which would be at the end of the list. So I would say temp is equal to head. Now I would traverse the list while temp's next is not null. So when temp's next is null, that means I'm at the last node. And since I'm at the last node, I can just perform the assignment of two links. Temp's next to this new node's previous to this temp. Fine. And in the end, you return. Now, so let us check insert at tail. So I'm inserting 1 at tail, then 2 at tail, then 3 at tail, then 4 at tail, and so on. So my list, when it would be printed, it would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that is the thing that we are actually expecting. Let's just see if that is the case or not. So wrong place, G++, and what do we compile is this main.c, and this compiled without errors. That's a good sign. Now let's just try a.exe, and okay. So constructor called when you initialize this doubly linked list object. Then for I is equal to 1 to 10, this one, you actually inserted that to the tail and you printed that. So when you printed that, you would have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 as expected. And then the destructor is called. Now to see how constructor and destructor are written in this, just check my previous video. But I hope you are able to understand how are we actually inserting at the tail in a doubly linked list. Okay, so we print this and yep, we return 0. So that is inserting at tail in a doubly linked list. Okay, so that's about it. This is a small video. In the next video, we'll see that how do we actually add a node in between of the doubly linked list. So it could be the head, it could be the tail, or it could be any value, any position in between. So that's it for the video. Hope I was able to explain something to you. And yep, thanks for watching, and I'll see you in the next video. Bye.